Hello and welcome back to Advent of Code 2023, day 11. Dear Jay, thanks so much for the subscription. Okay, so slightly earlier than yesterday. Yesterday's was a pretty tough, quite tough problem. Not terribly tough, but quite tough. So I don't know what to expect today. 11, Cosmic Expansion. Ooh, looks like we got something to do with 2D grids. That's all right. Okay, let me grab the coffee. He is still in process. All right, cosmic expansion. We continue following signs for hot springs and eventually come across an observatory. Let's make the mandatory wiki click. It's an observatory. That's a cool looking observatory. That's in the Swiss Alps. He's in Hawaii. Okay. The elf within turns out to be a researcher studying cosmic expansion using the giant telescope here. He doesn't know anything about the missing machine parts. He's only visiting for this research station project. However, he confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there once he's done with today's observation analysis. Maybe you can help him with the analysis to speed things up. The researcher has collected a bunch of data and compiled the data into a single giant image. The image includes empty space and galaxies, for example. That's a very straightforward input. Okay, we can parse that easily. It's nice and regular. Second. Okay, so the researcher is trying to figure out the sum of the lengths of the shortest path between every pair of galaxies. However, there's a catch. The universe expanded in the time it took the light from those galaxies to reach the observatory. Welcome back, dear Jane. Thank you for the subscription. Have the puzzles gotten hard again? On first glance, I would say this doesn't, well, look hard, but then the moment they said the universe expanded, I don't know, I feel like it could be some nasty trick to this. Let's see. So far we know we've got this map. Very nice, straightforward input with empty space and galaxies. Okay. And now they're saying we want to find the shortest path between every pair of galaxies, which I mean, that would be very easy as is. But okay, now they're saying the universe expands due to something involving gravitational effects. Only some space expands. In fact, the result is that any rows or columns that contain no galaxies should all actually be twice as big. So you look at the rows and columns that have no galaxies. And you duplicate them essentially. Okay. These rows and columns need to be twice as big. Alright. Equipped with this expanded universe, the shortest path between every pair of galaxies can be found. It can help to assign every galaxy a unique number. Okay. So, once we've done the expansion, then it's just a fixed map, right? No more tricks. And then you just do the standard shortest paths, all shortest paths approach, which is well, wait, so up, down, left, or right? Okay. So it's just, but that's just Hamming distance. We don't need to do much. All right. It's just, we don't need to do a breadth first search or anything. We can find that using the coordinates pretty straightforwardly. Sum of the shortest path between, it's basically the Hamming distance. Okay, sum of the Hamming distance, not Hamming distance, sorry, Manhattan distance. Hamming distance is 0, 1. What's Hamming distance? No, Hamming distance is a cryptography thing. Based on digits of, it's not relevant here. All right, so, minimum of 9 steps to get from the galaxy 5 to 9. Expand the universe, then find the length of the shortest path between every pair of galaxies. What is the sum of these lengths? Alright. I have a feeling they might do something for part 2 that means whatever we do for part 1 is kind of... So if we just do, I mean, we could just do this approach and the way they've described it, and that will get us part 1. But I have a feeling for part 2, we want to have something which is more generic, like handles an arbitrary number of expansions and moves. All right, doesn't matter. Work with what we've got. So, right. Python, new, Python file, 11. Nope, don't paste it there. All right, so this is easy to parse. We just say, there's an empty line there, just remove that for. Alright, so with open input for line. Alright, so just say grid equals just list. Now, should we do the expansion as we're reading the input? Can that be easily done? So if we see a row, thing is, well, we need the original input for part 2. Will be easy to get. But okay, so if we were to do the expansion as we're reading it, we'll know that if there's an empty line, We would have to add it twice. I think we'll do expansion separately. Alright, so for line and effluence, grid.append row.strip. And I think I'm gonna make a list, because if we want to expand stuff, then we might want to be working with a list so that stuff can be actually expanded. Lists are mutable. Strings are immutable. Okay. We'll define this as a method. Define expand grid. Alright, so do we just so it's should we start with columns then? So well, there's an easy way of doing this without having to. Columns is the tricky bit, rows is the easy bit, right? So all we need to do really is expand the rows, duplicate the necessary rows, and then transpose the grid, which means just reflect it in the diagonal so all the rows become columns and vice versa. And then just do the row thing again. So transpose. How do I transpose again? It's so it's gonna be J. Hang on. Grid IJ for I in. First, we've got to keep track of N's and M's here, so. Because the lengths and the lengths, heights and widths are going to change now, and they might not even match because we might add rows but not add as many columns. So n equals. Actually, we can write this independently. So say grid row for row in length grid Is that the transpose? Let me try this out. So alright, so we want to print this nicely, so define pretty print grid. Alright, you know what? At this point, it makes sense to make grid a class. So let's say class grid. Right, and then grid equals grid. Should go and make this all nice and neat and complete. So let's say add row. Alright, so grid dot add row. Okay. So then we want a transpose method. Okay, so transpose, I would say let's create a new grid. And then we want for j in range. You can't, what have I done here? Why am I, that's not how you, okay, I should have used ranges. Okay, so anyway, we're writing it fresh now. J in range. Length of grid 0. Hang on, come on, let's write all the methods we need. So define width. Okay, so transpose, so it's going to be right, so for j in range that, we want to do new grid dot add row. So it's going to be basically this. Grid, all right, so just do ij for I in range self dot height. Return new grid. Is that right? All right, well now it's time to do the printing and see what it looks like. So we want to join up all the rows basically. Okay, so with all this, print grid. All right, let's have a look at grid. All right. And now let's try, so does that look like that? Yes, it does. Now try print grid dot transpose. Okay, so it should look like the original grid, but reflected in a diagonal. So that 1, 2, 3, 4, 5 now goes up there. This one, so it used to be 1, 2, 3. 1, 2, 3. It's now there, and it's got 1, 2, 3, 4, 5. Yeah, it just looks, because of the line width, it's looks a bit off, but it's fine. Yeah, it's correct. Okay, so we've got a transpose method. So now I can use that. All right, so we want to define an expand method. All right, so let's just move this one up here. Okay. Define, so we want expand. So we're going to return a new grid. So, okay, let's think. Okay, so G equals self dot. Okay, first we transpose it. Right. Then we look at each row. And every time we see okay, we look at each row starting from the bottom, working backwards, because if you insert rows, you won't mess up the index that you're looking at. It's just a cleaner way of doing this. So for I in range, so it's going to go from length of the self dot height. We should actually do G dot height. Go backwards. If G dot if so okay, so we want to say if all car is dot for car in G dot rows I. So if it's all dots, then we're going to duplicate this row. So rows dot insert so insert, you need to say at I, we insert a new row, which is going to be whatever G dot rows was, and use that to create a copy. All right. And then we transpose that. Let me just do that again. and then return G. Looks a bit messy. Duplicate code fragment. Yeah, well, we'll allow it. All right, so so let's try print G dot I in range. Oh yeah, sorry. This should be -1. All right, so let's look at this then. So we've expanded. Maybe it's better to use the example they've given, because we know what it should look like. So that is the example. Let's paste that in. And that is the expanded. So it should be like the original, but bigger. So there's 4 on the left instead of 3. And then there's 1, 2, 3, 4, 5, 6, 7, 8 afterwards. 1, 2, 3, 4, 5, 6, 7, 8. All right, that looks correct. Okay. Took me a while. But now we've got a nice object-oriented approach here, so what are we actually doing? We are finding we're finding the sum of sum of distances between all pairs of galaxies. Okay. So we need a new method. Define distance between 2 locations. So this is going to be a graph method as well, so this is going to be completely full of methods. So it's going to be I1, I2, I1, I1, J1, I2, J2. Return absolute value of I1 minus I2 plus absolute value of J1 minus J2. That's the Manhattan distance. All right. So what do we need to do now? All right, we need to find... First, let's create a set of all galaxies, all right? Galaxies equals set. Let's say grid equals grid.expand. So we expand it. We destroy the old grid. We don't really need it. Galaxies is a set. All right. So for row in grid.rows. Hello, Mara. Yeah, it seems, well, part 1 seems easy. I mean, it's taking me a while to code, but I guess I'm trying to make it really nice and neat with all these methods. But now I should be able to get part 1 easily. $140 by $140 collision thing. Alright, let's have a look at this. Yeah. I mean, yeah, that looks like the ASCII version. Yep. Well, I don't know what part 2 is, but I'm guessing then it won't be that hard. I thought they could do something really tricky with the expansion of the grid, but now I can't really think of what you could do that would be really that tricky. So, all right, let's get part 1 done. So, what am I doing here? Oh, for row in grid.rows, for call in, so we should be doing grid.height in range, for call in range, grid.width. If tell you what, let's throw another method into the mix. So define get. That gets us the item. All right, so if grid.get row call is a hash, okay, so we've got a set of galaxies. Now what? Just add up all the distances, so just make it a list then. Because we're not going to get duplicates. All right, so for I want but at this point there's no reason to have this dist method as a grid method. We'll just do the calculation outside. So got total equals 0 or G, so for I1, J1 in galaxies, for I2, J2 in galaxies. And it doesn't matter if we coincide here because the distance will be 0, so we can just add those on anyway. So total plus equal, it's going to be that. Bad Cop, hello, thanks for the follow. And thank you also for the follow, the Furax Fox. Are you doing Advent of Code as well? Nice, have you already done today's problem? So now just print total, that should be it for part 1. That was probably the longest part one I've done, but I made it all nice and neat and like a good piece of software. All right, so let's just run it. 748. Like a good boy, yes. My old manager would be proud. Oh, it's wrong. You're stuck. Make sure you're using the... Ah, no, it's gonna be half that because I'm adding everything twice. So I just gotta wait 1 minute now before I can submit again. But yeah, it's gonna be 374. Yeah, because I added every pair of galaxies twice. Alright, so while we're waiting for 1 minute to pass, I can have a quick look at the leaderboard. Let's look at the stats. It's difficult at this point to really glean anything from the stats because other than the ratio of people that sold part 2. For example, this one, day 9, there was an overwhelming proportion of people managed to solve part 2, which is understandable because it's just changed the order. I think most people realize you change the order, or at the very least just insert at the front, which is an easy change. So yeah, that was pretty easy. Oh, and the leaderboard is... my private leaderboard is this one. Yep. Oh yeah, let me paste this as well in case anyone else wants to join. And the other leaderboard I'm on, Captain Coda, who might be streaming soon. I don't know when he starts streaming. I think normally in about half an hour. But he's mainly doing C#. And I quite like his stream, so I usually try and catch it each day, or a bit of it at least. Alright, so I'm pretty sure I can submit now. 374. Whoops. 374 is not correct. Okay. Not actually at the bottom of mine. What is your username here? Who just recently joined? Was it Penguin555? Oh, CGS Dev. Nice. Well, were you expecting to be at the bottom because you completed every star? Mine was almost 10 million, so you're not even in the same ballpark. Oh yeah. These numbers are way off. Okay, I've definitely done something... Wait. Some of the shortest parts... Oh, I'm still using the example input. Whoops. Yeah, I switched to the example input. Just to test out my expansion. Alright. Now for the big boy input. Wait, so for the example input... I'm at the bottom of most of the leaderboards I'm on. Wow, okay. Those are some competitive leaderboards. Well, my leaderboard and Captain Coda's leaderboard are... Maybe you'll feel better about yourself if you join them, because they have a fair few people who are just picking and choosing a few. Problems. 3. Okay, so now just run this on the full leaderboard. There we go, that's more like it. It said it was... okay. Okay, so can I submit now? Correct. Right. The galaxies are much older and thus much farther apart than the researcher initially estimated. Now, instead of the expansion you did before, make each empty row or column 1,000,000 times larger. That is, each empty row should be replaced with 1,000,000 empty rows. And each empty column should be replaced with 1,000,000 empty columns. Okay. You could actually probably get away with actually doing that insertion. In fact, wait, how big is this? But I won't do that. Let's write the nice way of doing it. The efficient way of doing it. So I think no more expansions. We just have to just add a marker to each row or column. And then when you're computing the distance, you can it's not that hard at all. You just look at which columns and which rows you're going to be covering, and then just add 1,000,000 for each of them. I mean, we could try running it for 1,000,000, just see if it runs, if it gets us the answer quickly. I don't think, well, how many expansions are we doing? It'll be in the hundreds of millions, but maybe, I don't know, let's see. I think it's a bit too big though. So if we were to expand, so it's going to be num equals 1. So it would be 4. We do this. This is grotesque. Don't do this. I'm gonna make a... No, we're not doing this. Because that's if you do this in both dimensions, that's pretty insane. Let's not do this. 1,000,000 in both dimensions. Alright, so the sensible thing here is to just create markers for all the rows and the columns which were expanded. Okay, so that was part 1. So part 2, wait, so actually we don't need to expand at all if we're using this new approach, right? So are you doing all the days in Python? Yes. I will. I'm going to stick with Python throughout the month. So if we're switching to this approach, we won't need to expand anymore. So let's just stop expanding. Let's hide that so we're not tempted to use it. So we're gonna have to, and that means we don't even need to transpose, don't need to modify it in any way. Now well, we can have an expand method, but it's not going to expand. It's just gonna conceptually expand. So it's just gonna keep track of where the expansions are, but not actually do them. So get rid of this. All right, so it's just gonna say, it's gonna look through all right, so it's just going to mark where all the just create a new variable called self dot expanded rows. Defined outside init. We can do that. It's naughty, but we can do that. For I in range self dot height, if all car equals dot for car in self dot rows, I then self dot expanded rows dot append dot add I, and then for j in range self dot width column equals, so it's going to be self dot rows I j for I in range self dot height, if all, basically the same thing here, so then we add self dot expanded columns dot add j. All right, so now we do that once, and then okay, so we go back to this and we say we want to compute dist between 2 points, taking the expansion into account. So we've got dist between 2 points and a value which basically tells us how much the expansion is. This is okay, so set is probably not ideal. We probably want a list. Ideally, you would be using binary search or something to make this super efficient, so you're not scanning through the expanded rows in linear time. Instead, you're very quickly identifying in logarithmic time how many expanded items are in your range. But I think we can get away with doing the slow way. So we're gonna say or we can get away with doing the really slow way, maybe. So we're gonna say for I in, so we're gonna have to add I don't know, an offset. For I in range, it's gonna be from I1 to I2, so we want to start, we don't want to actually hit those two, so all the ones in between. If I in self.expanded rows all right, these should be, let's do this properly, these should be defined in the init. Offset plus equal expansion, and the same for the J's. And then you just do this, right? So this is not that efficient because you're using, for every distance you're computing, you're using linear time to scan, to actually look through this range. So overall, we're doing kind of quadratic time search, and for each one we're using linear. For each pair, we're using an additional linear time. That's fine. I think that'll work. All right. But if you wanted to do this absolutely efficiently, you would use binary search. You would have these in a sorted array, and then you would use binary search to find the kind of the insertion point for this, and you would then immediately know how many in between them. Everything will be logarithmic. All right, so if I were to do this, then so it would be total part 1 and total part 2. Total 1 plus equal, so it's going to be rid dot dist, and this allows us to do both types of expansion without changing anything. So it's going to be I1, J1, I2, J2, 1. And then this one is 1, 2, 3, 1, 2, 3, a million. And then part 2 is just that. So it should be quick. Yeah. Is that still the number we had before? Let's check. 9742154. Oh god, it's wrong. It's not the same one we had before. What have I done wrong? So the expansion, we add divided by 2 is so lazy. Part 1 is wrong, so we need to check that we've got the right expanded rows and columns. Thanos snap half of it. Alright, I guess the most important thing is check that expand is right, because this is a bit wordy and not... I've done repetition here as well. I am range self height if all are dots and we add I, 0 indexed I. Okay. For J in range, self dot width, column is this bit right? Column is that. For I in range height. Could be. We expand once. What happens if we expand 0? 933, which is less than our original answer. And if I expand 1, 95, still less than our correct answer. All right. I could try the example. .5. You want to add expansion of 0.5? Or what do you mean by that? Can try that. That's what you get. What would that mean? Means you add like half a row's distance for each row. I don't think we need to do that though. Do we? Well, No, because I don't think we're adding double what we're supposed to when it comes to expansions. I think one was... Right, well, let's go back to the example. And make sure we've got the right... Because we've got markers for exactly which rows and columns we're supposed to expand on, so... Make sure we got those correct. Okay, 333. Okay, the 333 is wrong. We knew it would be wrong. Okay, so let's print grid dot expanded rows. Manually expand the input. Well, in this case we won't have to because the I'm using the test case now. Let's see if we can debug it on this. Alright, 3 and 7. Is that right? Oh, I think we've got an extra column here. No, that's right. Okay, so 3 and 7. So it's 0, 1. 0, 1, 2, 3, that's correct. 4, 5, 6, 7. 3 and 7 is right. 8, 2, 5. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we've got the right columns and rows. Maybe my arithmetic is wrong where I'm adding the expansion. Did I not think that through correctly? Alright, so if we want to find the distance, let's pick one specific distance. So we want to find the distance that they've given in the example, which is between galaxies 5 and 9. So in other words, it's going to be... Alright. Just after all this, let's do... Right, so it's going to be grid.dist. So it's 5, 1, and then galaxy 9 is at the bottom there, so it's 9, 4. See what this is. We need a expansion 1. Okay, it says distance 9. Is that right? Correct. It is distance 9 for those two. And that covers 1 row and 1 column. Okay. So that one distance is correct. Let's just try printing this at every step then, I don't know. So we've got a bunch of numbers here, so we should have... Does dividing by 2 still make sense here? Yeah, because the disk should be the same. Oh, I see the problem. It's because of this range. It's not correct. It won't use the range correctly if we're going backwards. Alright, so whoever pointed out that I was being lazy with this divide by 2 actually was onto something. Because if I2 is smaller than I1, then it's not gonna do this right. Okay, so I should go forwards. Alright. Fuck. Alright. How do I do this? So let's say 4 K1 galaxy in enumerate galaxies, right? For K2 in range... Wait, no, we don't even want to... No. The problem wasn't which order we do the galaxies. The problem was... In principle, our disk method, it shouldn't matter which ray we're going. Okay, so we just need to fix this range thing. So if we're going... So what does it even mean if you're ranging from... If you have a bigger number and a smaller number, what does it even do? Let me see this. So 9 to 5. Yeah, okay, print. I don't think I've ever done this. It's empty. Got it. Alright. It tries to increase from 9 and it never gets to 5. Okay, fine. Funny, you'd have thought I'd come up with this situation. I'd hit this problem many times, but I can't remember any occasion where I've had this issue. Alright, so let's just say... min... Well, is there a way to just hack range to make it... It doesn't actually matter. Let's just do mini equals min I1 2 maxi equals max I1 2 for IM range mini to maxi. Suppose you could make an iter instead of using a range. You could make an something which doesn't actually matter. Let's just finish this. So we're still making the computer do double the amount of work. What is the IDE complaining about with the squiggles? So some of these it wants extra spaces after the methods, which, yeah, I suppose I should. Some of them it doesn't like that I've reused variable names from outside, but in these coding problems I kind of like to use the same variables because it helps me keep track of which ones I'm using in which methods. But yeah, that's something you normally shouldn't do, because I've used I1 outside and then I1 inside. So, you know, if I were to stop using this one, then it would default to using the one that was stored from outside, and that would be really bad because then you're using the wrong value. These, it just wants spaces. I don't particularly want to. Yeah, shadowing row from outer scope. Yeah, those ones I'm ignoring, but 2 blank lines, yeah, we can do that. Okay. Alright, so if I do that, 374, and they didn't give, okay, fine. Switch back to so 9742154. Okay, that's correct answer to pipe 1. Let's try this one then. No, it's wrong. Too high. Weird. All right. Alright, so did I copy in exactly? Yes, I did. Alright, fine. Alright, let's go back to the test example because they've actually got an answer for if we were to expand 100 times instead of 1,000,000. Making a mess of this. I don't see what could be wrong. Maybe it's the arithmetic is wrong if expansion is more than 1. If I sort of added expansion once for each row that's in there, mini +1, maxi, mini, so I'm not including the min and max. All right. Oops. Okay, go back to this input. So if I do 100 instead of 1,000,000, 8492. Ah, and it should be 8410. And if it's 10, we should get 1030, but we're not going to, are we? 1112. What the? So it works for expansion 1, but not for... I think my logic is wrong with this expansion. Is wait, I think this is a verbal problem. Hang on, so when you expand... Oh... What's the expansion added? 1,000,000? Technically, no. It's added 99999, hasn't it? it's multiplied the space by 1 million. So when we added 1, we actually doubled. So we actually multiplied by 2. Ah, I get it now. So expansion. What? Okay. So what is the semantic meaning of expansion? What do we want to stick with? We want to say... We want expansion to be the factor. Okay. So in the basic case, we want to do... Well, not expansion minus 1. Well, okay, it depends what we actually mean by expansion. Okay, so if I want expansion to be the factor, then the basic case should have been 2. And the big case should be 10. So multiplying by 2, multiplying by 10. And then in this... In this case, we use expansion minus 1, yeah. If I let expansion mean that. Is that what I mean? 374, 1030. Yep, and we should get 8410 for 100. Yeah, that was a problem of semantics, but yeah, that's an easy trap to fall into. It's the way they word it. I bet ChatGPT would make that mistake as well. Alright, so that I don't see any problems now. That should just work, right? So it's a scaling factor, not an arithmetic offset factor. Yeah. You said 999,999, but forgot to add the -1. So I'm letting expansion be the scaling factor, and then I'm doing the -1 here. So that this amount is how much it's added arithmetically, but I want expansion to mean like what scaling factor a row gets multiplied by. So basically empty rows get doubled, empty rows get multiplied by 1 million. So that gives me this. All right, let's check this. All right, site is processing. I've got 2 tabs open. You shouldn't do that because sometimes it gets confused. Again, go back to the page, go through here, just in case it's hanging on to any old, I don't know, cookies or inputs or whatever. All right, there we go. Okay, I got there in the end. It's not a hard problem, but one semantic mistake and one just mistake with the way I'm using Python ranges. So, yep, lots of people have, oh yeah, it uses this local scoring thing. I don't like that ordering. I like ordering by stars because I think number of stars should trump all. Yep, that's cool. Lots of people getting full stars so far. Marrow, I see you've done that now as well. And Captain Coda. Oh, speaking of Captain Coda, will Captain Coda be streaming anytime soon? I don't know. Don't think so. I haven't seen anything in his channel, so probably within the hour, but not right now. So mine's a bit of a mess. Let's have a look then. So was it pretty much the same approach as mine? What is this? What language is this? Okay, I cannot read that. What the? Okay, that's interesting. It's Bash. Wow. Oh yeah, .sh. Alright, part 1 is much more readable. So part 1 you actually do the expansion fully. Yeah, okay. That's cool. So for this day, I don't think it would take people long. 3 minutes 37. Yeah, for the top competitive programmers, there's nothing hard here, really. Alright then, I assume, just check one last time in case the Captain Coder is actually live, otherwise I'll just
No, I'm not saying that's a problem.
next stream in half an hour. Alright, well, anyway, I'll give a shout out to the Captain Coder because he does a good stream, which is usually after my one finishes, depending on how long I take. So if anyone's interested, I'll just post his username there. Should get a really hard one soon. I'm sure we will. I'm sure we will get some assembly code, at least one assembly code problem at some point, but I think he will reduce the amount of assembly code compared to 2018, because that was kind of wild. That was the last one I did. Hello, Ion lol. Yeah, so we've just finished this problem. Which day is the hardest in your opinion for this year? I guess it might have been yesterday's, just because, yeah, I would say yesterday's, which was day 10. Really loved the int code year. Which was the int code year? Day 5, part 2. What was this? Oh, yeah, that... Yeah, conceptually, it might have been quite hard to come up with a solution for this one. I think when it comes down to my code, I feel much more confident with my day 5 code than my day 10 code, because at the end of the day 5, my range, once I get my range method right, you just apply it like 8 times or whatever. So, yeah, day 10 I had a nasty exception, a nasty edge case that I had to handle. So I think day 10 coding wise was harder for me. And it seems like for day 10 there is a wider variety of approaches that people have taken. I've seen some people have used string lace formula shoelace formula. This calculates the area of a polygon. So if you calculate the area of the space enclosed by the loop using this formula, and I've never really used this, that would then give you the, well, once you got the area, you know how many cells there are. It's not entirely trivial how to calculate the area, though, to apply this theorem, but it works, apparently. Where is the actual... Oh, so it uses, like, determinants or something. Yeah, so there's the flood fill approach, where you just got to keep track of, I would say, all the cells which are bordering your loop, and make sure you know which ones are inside and outside, which you can do with one walk around the loop. I would say start from the leftmost, because then you know whatever's to, if you're going up, you know whatever's to the left of you must be the outside, because there can't be any further loops to the left of you, otherwise it wouldn't be the leftmost. So at that point, every time you make a right turn, you know that the outside will be on your left, and so on. So can I link my little visualization video? Yeah, you can link it. Is it a YouTube, or is this the Rainbow Islands here? We may eventually reach Rainbow Island. So yeah, there was the flood fill approach, and then there was the approach which I did, which was the raycast approach, raycasting, where you cast a ray from a cell to determine whether you're inside the polygon or not. But that one works, but it's nice. I hadn't actually seen what it actually looks like, what the pipe actually looks like, but yeah, that's pretty big. Space filling pipe. Cool. Oh, it's still going. So what? So okay, that's the pipe, and then what? You flood fill starting from what you know to be the outside, and then what? How do you then go to all the pockets? You just keep track of what's still outside by walking along the loop. A flood fill twice. Only twice? Are there not an indeterminate number of outside pockets which are kind of in there, wedged in there somewhere? So it floods the outside with green, then black. Uh-huh. Which erases all of them. Oh, okay. Alright, that's interesting. I saw that some people even solved it in Microsoft Paint. They literally just took a picture of their, well, they made a pixel image of the pipe and everything. They pasted it in Paint. They used the paint bucket tool. That was you? Wait, but this is um. Oh, okay, fine. But yeah, it can be done that way. But then then you could have to use some sort of maybe Python imaging library or something to actually read the pixels, unless you're going to count them by hand, which I saw some people actually did. But you could, yeah, that can be done as long as you're keeping the pixels consistent. Then counter by hand, then automated it with image magic. Okay. Yeah, so I would say on that basis, 10 is probably the most interesting problem, simply because so many people came up with different, wildly different solutions. Um, if I were to repeat it, I would probably go with the flood fill approach because I feel like it's the most reliable. Like, because my raycast approach is the code. I've coded it based on a very specific property of the input. But the flood fill approach, you wouldn't need to exploit any input, any properties of the input or anything. You wouldn't need to specially code it. It should just work, no matter what kind of weird shapes the input would take. So I feel like flood fill approach is really the textbook canonical approach. Wish they picked better characters. What characters would you suggest? I don't think there really are better characters, are there? Or at least from the standard set. I mean, it makes sense that you'd want to keep it as pre-post them to Unicode. Oh, Unicode borders. Well, yeah. Then there'd be issues with some people reading the inputs, I guess, if they're not prepared for that. Yeah. And then some IDEs might do funny things with them. Could I screenshot this and solve it in Paint? Yeah. Is Paint, like, I've never tried using Paint Bucket for something particularly complex. Does Microsoft Paint ever slow down when using the Paint Bucket on something big like that? Does it ever like actually? Oh, it actually slows down. Wow, I've never seen that because I've never attempted to use Paint Bucket on something complex. Wow, that's cool. What does it look like? Does it just not do anything and then it fills it? Or does it actually fill gradually? Because that's pretty cool. Just freezes. Yeah, that makes sense. I don't think they would want it to do it gradual because that'll I think it won't be clear when it's done if they did that gradual thing. All right, so yeah. So tomorrow, what do we think? Harder or easier? I think harder, probably. If we're assuming he likes to alternate. All right. You'd have to pause to draw and swap buffers and upload to the GPU and all that in the middle of the flood fill. Yeah. I mean, it could be done. I don't know if the original Microsoft Paint, the original edition, whether there'd be a difference with the new one. All right, I'm done. I need to go to the supermarket. But yeah, Captain Coda probably be starting in like 20 minutes or something. So thanks for watching, everyone, and I'll see you tomorrow around the same time. I guess I'll try to go earlier if I can, leave myself more time in case of a harder problem. So possibly earlier by a couple of hours at most, but otherwise around the same time. All right. See you guys next time.